This video is going to be part B of our probability notes for the probability lessons that we've been doing. So the learning target, if you can please write this on your note sheet, I can find the probabilities of compound events. The first vocabulary term that it's important to understand is compound event. That is the union or intersection of two events. So remember, an event is an outcome, something that could take place when we're doing some kind of experiment or probability problem. An intersection, or the word union, generally you can just think of it as something that crosses over or crosses with another event, and there is some point of similarity. So intersecting means that there's a point of similarity, and that's what we might have if we were drawing a card from a deck of cards. We could look at the probability of a card being an ace and part of the suit of clubs. So how many cards are both ace and a club? So that's where that would intersect. Now the next vocabulary term is overlapping. Two events are overlapping if they have one or more outcomes in common. And oftentimes we'll use the Venn diagram to find overlapping events. And so we are familiar with the Venn diagram probably from previous lessons, not necessarily in math, but the point where those two things overlap is this little shape here. So some things will have, distinct characteristics, and then some things will have things in common. And those things in common are what we call overlap. We're going to need to know what to do with events that have overlap. And then finally, in our vocabulary section, we want to know what disjoint or mutually exclusive events are. These are two events that have no outcomes in common. So they don't have anything to do with each other. They don't have any commonalities at all. And we are going to take a look at the first example. And we have a picture of the 52 cards in a deck of playing cards. A card is randomly selected from a standard deck of 52 cards, and we need to find the probability that the card is a 5 or an ace. Notice that it's a disjoint event that we're trying to find. Now, do 5s or aces have anything in common? Not really, except they could be from the same suit. But they're not asking us about that. They're saying what's the probability of the card being a 5, and what's the probability of the card being an ace. Okay, so the P here stands for probability. How many cards in our deck of cards are 5? Well, we'll look right here, and we see that there are 4 out of the 52 that are 5. They have the number 5 on them. All right, and then we also have 4 cards that are aces. Now, if you were going to think of the word or, do you suppose we would subtract these two numbers, or would we add them together? If you're going to do something or something else, then how many choices do you have in total? You have 2 choices. So that means we're going to add them together. And so the probability of drawing a 5 or an ace is 8 out of 52. However, we need to reduce that, because we don't want to leave our probability in a non-reduced state. So when we reduce that, 4 goes into 8, 4 goes into 52, and my probability is 2 over 13, or 2 out of every 13 cards could be a 5 or an ace. All right, let's go on to example 2. We're going to find the probability of overlapping events. This is where something is in common between the two events. All right, so a card is randomly selected from a standard deck of 52 cards, as we see on our screen. What is the probability that it is a club or a 3? Okay, so we need to find out what's the probability of it being a club. How many clubs are there in the deck? If we look up here, we see all of these clubs. Okay, and there are 13 of them. And what's the probability of one of the cards that we pull out being a 3? Well, there are 4 different cards that have a 3 on them. Now, if you look at what I've circled on the diagram of the 52 cards, there is a point of intersection. So wherever they intersect, whatever the part is that they both share, so there's something in this group that is shared by both the club group and the group that I circled that have 3s in them. Okay, so that means that we counted the card 2 times because we counted it as part of the club group and we counted that card as part of the group of 3s. So if I say that there are 17 out of 52 cards, that's not true, is it? Because there are 13 in the clubs, but then there's these other 3 outside of that that would be counted in total, because we cannot count this card 2 times. Okay, so what do we have to do? Well, we have to find out how many are the overlap, and then we have to subtract the overlap. Once we subtract the overlap, in this case we have 16 out of 52, but we need to reduce. Number 4 goes into 16, and the number 4 goes into 52. So our overlapping event probability is 4/13. And so I just want you to remember from this example, we are going to subtract the overlap from the original probability that we find so that we don't count that item in both groups and then give a false probability. Okay, for example number 3, we're going to be using a formula to find the overlap. So we're going to abbreviate the overlap in our formula as the probability of A and B. So you'll see that over here to the right. That is considered the overlap. And we know that we have to subtract the overlap so that we don't give a false probability. If we have 2 events, probability A and probability B, these are the probabilities of 2 different events taking place. And it looks like at the end, after we subtract the overlap, we get a probability of 0.6. So our formula that we're going to use, I've written over here to the right, so we have to just plug in the numbers that we've been given. We know that the probability of A or B taking place is 0.6. That's going to be equal to the probability of A plus the probability of B, but we then have to subtract the overlap, which they didn't give us in this problem. Remember, the probability of the overlap is the probability of A and B, those together. We don't know what that is. This doesn't have a picture. It doesn't give us any details of what probability events were taking place. So we just have to plug in the values that were given and use a variable for the item that they're asking for but have not given us. So we're using x as a variable here, and we just need to solve this algebraically. So we have 0.6 equals 1.02 minus x. The next step is going to be to subtract the 1.02 from both sides, and I get negative 0.42 equals negative x. And you probably remember from previous algebra problems that we can divide by -1 or multiply by -1 to turn all of that positive. So our overlap for this problem is going to be 0.42. Now another way to say that is going to be 42%. You could turn it into a percent, but this is just the probability of the overlap itself. For the front side of this page, you have 3 practice problems to do, and each one of these problems has already been done for you. Example 1 is just like number 1 here, example 2 is just like number 2, and example 3 is just like number 3. So try those out, try them on your own. If you have some questions, make sure you ask about them in class tomorrow. On the back side of your notes, you have example 4, and it's asking us to find probabilities of complements. Complements are the probability of something not taking place. So it's the opposite of the probability. And so for instance, if I was thinking of the weather, if it said that there is a 70% chance of snow, then the complement to that is that there's a 30% chance that it won't snow. And if we look at the dice over here on the right-hand side of your page, I did notice one error. This die right here should have 2 dots on it. So if you could add that other dot in there, please. And so we have 36 possible outcomes of rolling 2 dice. And if you think that there's not 36, the way that you can think of this is if you roll 1 die and you get a 1, and then you roll a second die, you could also get another 1. And some of you are thinking, well, there's actually some repeats in here, and it looks like there's repeats, but if you roll the first die and you get a 2, then you could get a 1 the second time, even though it's looking right here, this is a 1 and this is a 2, but we're talking about rolling them separately, okay? So make sure that you understand you're rolling one and then you're rolling the other, and these are the 36 outcomes that could take place. So we are asked to find the probability of the sum of the 2 die being less than or equal to 3. So if we add up the top sides of the dice, the sum has to be less than or equal to 3. So I'm just going to circle the ones that are 3 or less, and these are the only 3 that I see. So 3 out of the 36, or 1 out of 12, have a sum less than or equal to 3. Well, that means then that the rest of these 36, there's only 33 left, right? Those have a sum that is greater than 3. So 33 of the 36 are greater than 3. And if I reduce this, I'm going to see that 11 out of 12 are greater than 3 then, overall, out of the entire set. So here's the complement. This is a complement to the 1/12. If we add these two together, if we add 1/12 and 11/12, then that's back to being a whole 1, which is what we want, because if something doesn't happen, it's the complement. Okay, so we're just subtracting our value from 1 to find the complement. For example number 5, we're going to use the idea of a complement in real life. So there's an annual salary study here. It says that a university conducted a national research study of recipients of PhD degrees. Those people that earned a PhD degree had annual salaries greater than $95,000. And the amount of people that had that was 0.834, or 83 let's put this in a different perspective. 83.4% of the people earned more than $95,000. So our question is, what is the probability from this study that an annual salary of a PhD person who had a PhD is less than either $95,000 or less compared to people earning $95,000? So I'm just going to take the number 1 and subtract my decimal, 0.834. And so I'm going to find out how many people don't earn $95,000 or more. And that is 0.166, or in other words, 16.6% of the people earn $95,000 or less. So looking at the percentages, you can tell that the majority, 83%, do earn more than $95,000. But there are some people, a small percent, that earn less than $95,000. Again, a complement is taking the number 1 and subtracting the decimal form, or if you had this in a fraction form, you'd need to subtract it from 1 anyways. All right, so let's take a look at the on your own problems down here. I'd like to point out that this is the notation for the complement. So if you see the P, which stands for probability, and the A with the bar over it, that means that you're finding the complement. So for number 4 here, I want you to take 0.63 and subtract it from 1, because we want to find out the probability of A not happening. So this is the probability of A bar, okay, and that's what you're going to find once you subtract 0.63 from 1. You're going to want to do that with numbers 5, 6, 7. And then also, you're going to do this same problem that I just showed you a second ago, but this time the percentage is 0.668, or you could say that it was 66.8% of those earning a PhD degree did earn money, amounts more than $95,000. But this time, you're looking for probability of it not taking place. All right, so please write down any questions that you might have or circle some problems that you are having difficulty with, and then we'll look at those questions in class. Thanks for watching.